this video, we are going to attempt some of the questions, multiple choice questions related to stoichiometry, and that is for AP chemistry. So first question says that 6 gram of calcium carbonate decomposes to produce 2.73. So it says 2.73 gram of calcium oxide according to following equation. What is the percentage yield of calcium oxide? So first of all, the mass that has been given to us, and that is going to be the actual yield. Always the mass that has been given to us, that is the actual yield, and the theoretical yield we are going to find from the equation. They are given us 6 gram of calcium carbonate. So first I am going to find the moles of calcium carbonate. The formula is going to be mass, which is 6 gram, divided by molar mass, which is 100.09, and the moles that comes out to be is going to be 6 divided by 100.09, 6 divided by 100.09, and that comes out to be 0.0599, 0.0599. So now we need to find the moles of calcium oxide because we want to find the theoretical yield. Unknown I am going to put on the right side. So unknown is calcium oxide. First we are going to take it from the equation. It is 1:1. So if this is going to be 0.0599, it is going to be x, and it is going to be cross multiplied, and x comes out to be 0.0599. So calcium oxide moles are 0.059. So from this moles I am going to calculate the mass, which is going to be the theoretical yield. So mass is equal to mole times molar mass. Mole is 0.0599 multiplied by molar mass, which is 56.08, and that comes out to be times by 56.08, and that comes out to be 3.36, and that is the theoretical yield. Then the formula is going to be percentage yield is actual yield divided by theoretical yield times it with 100. So actual yield is 2.73 divided by theoretical yield, which is going to be 3.36, times it with 100. So let's find out the theoretical yield, and the answer comes out to be, that is going to be B. Okay, that is going to be B. So for this question, they are saying the neutralization of magnesium carbonate proceeds as follows. How many liters of carbon dioxide are produced when 13.6 gram of magnesium carbonate reacts completely with excess HCl at standard temperature and pressure? So in this question, first we are going to find the mole of calcium carbonate. So magnesium carbonate, that is going to be mass divided by molar mass, and that is for magnesium carbonate, molar mass is 84.31. So moles comes out to be 0.1613 mole. So now we need to find the volume of carbon dioxide. For that purpose, unknown is going to be put on right hand side, and known, which is magnesium carbonate, I am putting on left hand side. From equation it is 1:1. So if it is going to be 0.1613 moles, it is going to be X, and X also comes out to be 0.1613 moles. Now, we need to find the volume of carbon dioxide. For that purpose, for the gases, there is a formula that is mole is equal to volume of gas divided by molar gas volume, which is 22.4 liter. Mole is how much? That is 0.1613, and volume of gas is, we need to find out, divided by 22.4, and volume of gas, that comes out to be 0.1613 times it with 22.4, and the answer comes out to be 3.61. that is 3.61 liter. So answer is A. So in this question they say, in the following combustion reaction 0.60 gram of magnesium is burned with 0.60 liter of oxygen. So what is the limiting reactant? So first of all, this is available mass, and from available mass, the mass which is given, that is available mass. So this is available mass and this is available volume. First we need to find the moles. If we want to find the moles of magnesium, the formula is going to be 0.60 divided by 24.3, and that comes out to be 0.0247 mole of magnesium. That is available mole of magnesium. And then mole of oxygen is going to be the volume, that is 0.60 divided by molar gas volume, which is 22.4, and the answer comes out to be 0.0268 mole. So these both are basically, these both are available moles. They are available moles. And from these available moles, we need to find the required moles. And how we are going to find the required moles? So first of all, we have available moles of 0.0247 mole of magnesium. What I am going to do, I am going to use a table method. In this table method, here you are going to write the mole of magnesium from the equation. If we see from the equation, it is 2 mole of magnesium which are reacting with how many moles of oxygen? That is 1 mole of oxygen. So I'm going to write here. So first of all, you know, this mole of magnesium and mole of magnesium, they are going to cancel out, and 0.0247 divided by 2, that comes out to be 0.0247 divided by 2, that comes out to be 0.01235 mole of oxygen, and these are required moles. So if you see the available moles of magnesium, available moles of oxygen, they are greater than required moles of oxygen. That means oxygen is going to be in excess. If oxygen is in excess, O2 is in excess, then the other one is going to be the limiting. So magnesium is going to be the limiting, and our answer is going to be A. So the next question says, when 12 gram of calcium reacts with excess HCl and the reaction produces calcium chloride, they are saying what is the mass of calcium chloride. So first of all, we are given with the mass of calcium. So first I'm going to find the moles of calcium, that is mass divided by molar mass, and that comes out to be 40.08, so that comes out to be 0.299 mole of calcium. So I have to find the mass of calcium chloride. So for that purpose I need the moles of calcium chloride. So first I'm going to choose it from the equation 1:1, and if this is going to be 0.299, this is going to be x, and x also comes out to be 0.299. Now 0.299, and then I have to find the mass, and mass is of calcium, that is going to be mole time molar mass. So mole is 0.299 and molar mass of calcium chloride is going to be 110.98, and the answer comes out to be 33.2 grams. In the next question, they say nitrogen gas reacts with hydrogen gas to produce ammonia. So if 6 grams of hydrogen gas reacts with excess nitrogen gas, how many moles of ammonia are produced? So we need to find the moles of ammonia, and we are given with the moles of hydrogen there. So first from the equation 3:2, then if there will be 6 moles of hydrogen, then it is going to be x, then it is going to be cross multiplied, and it becomes 3x is equal to 18, and x comes out to be 18 by 3, and x is equal to 6 mole of ammonia. So answer is going to be C. So now we have another question. They are saying carbon dioxide gas is collected at 25 degrees Celsius and 1 atm pressure. The gas has a volume of 10 liter. How many moles of carbon dioxide are present? So for this question we are going to use the formula of general gas equation, ideal gas equation, which is PV is equal to nRT, and we need to find the moles. So n will keep here, PV divided by RT. P is the pressure, that is 1 atm, and volume is how much, that is going to be 10 liter, while the value of R is 0.0821, while that of temperature, for temperature we need to convert it in Kelvin, that is 25 plus 273, and that comes out to be 298 Kelvin, and that is 298 Kelvin. So the moles are come out to be how much? They come out to be 0.409. So answer is A. For next question, they say when heated anhydrous magnesium nitrate will decompose into magnesium oxide and mixture of gases. They have given us 1.48 gram of magnesium nitrate, and they ask us what is the mass of nitrogen dioxide which is produced. So for that purpose we first need to find the mole of magnesium nitrate, and for that purpose we need to have the molar mass mr of magnesium nitrate, and that comes out to be 148.33. so mole of magnesium nitrate is going to be mass divided by molar mass. Mass is 1.48 divided by molar mass, that is 148.33, and answer comes out to be 0.010 mole of magnesium nitrate. Then what happens? Magnesium nitrate you are going to keep on the left hand side, and NO2 you are going to keep it on the right hand side. From the equation there are 2 mole of magnesium nitrate and 4 moles of NO2, and you are given with the mole of magnesium nitrate, that is 0.010, and it is going to be x. So they are cross multiplied and become 2x is equal to 0.0 0.40 and X comes out to be 0.020. So these are the moles of NO2, and in order to find the mass, which is equal to mole time molar mass, 0.020 times molar mass, which is going to be 46.01, and that comes out to be 0.92 grams. Answer is A. And then for the next question, they are saying how many moles of which chemicals will remain when 1.5 moles of chlorine reacts with 2 moles of hydrogen. So first of all, they have the ratio 1:1. So if 1.5 moles of chlorine are reacting with hydrogen, that means first of all it is the limiting reactant. And limiting reactant, if it is 1:1, then it is 1.5 moles of chlorine that reacts with 1.5 mole of hydrogen. So if there is 2 mole of hydrogen, then 1.5 is going to be subtracted and it comes out to be 0.5 mole of hydrogen which has been remaining. And in order to find the moles of HCl that has been produced, so limiting reactant that controls the amount of product, so it is going to be we are going to put the limiting reactant, which is Cl2, on left hand side and HCl on right hand side. So first of all, from the equation we have 1:2. Then if it is going to be 1.5 moles, then it is going to be X, and X comes out to be 3 mole of HCl. So answer is going to be D here.